Hey everybody, it's Greenwood again with another tutorial video, and this is kind of a follow-up to the last GCF one with variables. So remember, we're looking for the largest factor that other terms have in common, and I wanted to give you an example here to try, or maybe two, so you could kind of try your hand at this and then see an explanation of that example. Okay, so here's my example, and so I'm just going to scoot on down here. You can see that example from the last video. All right. So here is your U try example. So I want you to do, let's go something like 12y plus 20y. Yeah, let's do that. Okay. So there's your problem to try. You're looking for the GCF, and you can list it, and then you can factor it out and list what the new expression would be with the GCF factored out. So now would be a good time to pause the video, try it on your own, and then come back and look at the solution. Okay, so hopefully you tried this on your own. Hopefully it went well and you feel like there's some success there. Remember, you can list your factor trees, your factor pairs, just like I showed you before. This isn't a step that's necessary, but I'm looking for the largest thing or the largest multiple these two numbers have in common. So I'm just going to go through it fast and list these for you so you know what to look at. 4 is the largest thing these have in common. It seems to like 4s lately. Remember, if you can intuitively see this, you don't need to do all that work. So y's, there's 1y here and 2y here. So the most I can take is 1. So the most they share is 1. So now I know my GCF is equal to 4y. So that means my factored expression will be 4y. And then once I divide or factor out my 4y, 12 divided by 4 is 3. One of my y's factors out. That means there's 1y left here. It's a plus. I almost heard a minus, but no, lots of minus lately. 20 divided by 4 is 5. And the y factors out, so I'm left with no variable. So I have 4y times the group 3y plus 5. Okay, let's do one more example, and then I'll let you try that one as well. Let's do something like, I don't know. How about we do 14z zz minus, how about 26zz? Okay, so here's one I came up with. Try this. Go ahead and pause the video. Do it on your own paper. And then I'll be back in just a second to show you how. Okay, so hopefully that went well. Hopefully the first problem helped you figure out the second one. So when I'm looking at 14, I know it's 1 and 14 and 2 and 7. I know 26 is 1 and 26 and 2 and 13. So I know my GCF by this factor tree. The numerical part, the coefficient is going to be 2. And then I notice I've got 3 z's here and 2 z's here. So 2 is the most I can take. So 2z. I'll put those little lines here to recognize that they're z's and not 2's or 7's. So it means 2zz is my GCF. So 2zz, or 2z squared if you want to think about it that way. So these 2z's pull out. I've got 14 divided by 2 is 7z. 26 divided by 2 is 13. And both z's come out to my GCF. And as a result, I get 2z squared times the group 7z minus 13. And if we're looking more mathematically correct, we should probably write it this way. And this would be the next step we kind of start thinking of. So 2z squared times the group 7z minus 13. Now, those don't look really like z's, but they are, I promise. Okay. All right. So there you go. There's a couple of problems to practice at, and I hope that helped you out. If you have questions, join live sessions or email me or message me on the help desk in Teams, and we'll see you in the next video. Bye.